Hi guys, today we're going to reverse engineer the complete learning framework developed by Ali Abdaal, a productivity expert, a YouTuber, and a former doctor. This goes deeper than tips and tricks. You're not here for isolated hacks. You want the full architecture, the engineering schematic, how these high utility components interconnect, and perhaps more important, how did Abdaal transform from struggling medical student into a top performer? The answer lies in designing a system, a data-driven approach. That transformation reveals the core paradox we need to unpack first. He started where most of us do, working longer hours and pushing harder. Then he hit a wall, hard. He discovered what we'll call the productivity paradox. Pouring in more time doesn't automatically translate to better learning or greater success. This correlation simply falls apart. The shift is documented across years of his work and came when he abandoned sheer volume. He pivoted to intelligent, evidence-based effort, not just the typical work smarter, not harder, but he systematized it rigorously. The critical insight is this. His success likely wasn't innate genius. It was a systematic approach grounded in principles of cognitive psychology, like make it stick. His system leverages those same principles. Today we're analyzing the mechanics of how he engineered a way to make knowledge stick efficiently, sometimes even painlessly. Our blueprint for today is this. First, we'll start with the mindset shift. While learning must feel difficult to actually work, we're going to embrace the discomfort. Then we'll get into the core engine. 3 evidence-based pillars: active recall, spacing, interleaving. These are the heavy artillery. Finally, we'll spend substantial time on the strategic toolkit, how to implement this daily with the retrospective revision timetable and Anki, but with a special twist. The aim is to translate theory into action. Before opening a textbook or launching a flashcard app, the entire philosophy of what learning is needs recalibration for most people. We will start with priority 1, the deep understanding. This is non-negotiable in Abdaal's system. Are you trying to memorize details before grasping core concepts? Then you're building a house without foundations. Catastrophically inefficient and exhausting. And any memorization you achieve is fragile. It won't survive long term. He used the Feynman technique to test this theory. In example, can you take a complex idea like recursive functions in programming and explain it clearly to someone with zero coding background? In doing this, did you use simple language? Used any jargon? Did you need complex diagram just for the basics? If the answer is yes, then you haven't understood it deeply enough. True mastery means grasping first principles so thoroughly you can translate them into simple analogies and everyday terms. And only when you have that clarity do you move on to memorizing specific facts and figures. This flows directly into the next psychological hurdle, desirable difficulty. Effective learning should feel effortful, challenging. It should be the opposite of conventional wisdom, where smooth sailing signals progress. And that comfortable feeling? It's actually a trap. A cognitive trap called the fluency illusion. Let me explain what happens. When you passively reread highlighted text, the words are right there, easy to process. Your brain registers that ease, that fluency, and makes a critical error. I think I know this, but here's the problem. Because you didn't retrieve the information. No genuine memory encoding occurred. It feels like knowledge, but you can't actually recall it later. When you find the material hard and you feel the struggle, that's your brain signaling it's actually engaged, doing the necessary work to forge connections. The goal, of course, isn't difficulty for its own sake. It's desirable difficulty, the sweet spot. If it's too hard, like attempting quantum physics from zero background, you just get frustrated. No learning happens. If it's too easy, like reviewing material you absolutely nailed last week, you're wasting your time. But that zone where you struggle just enough, that's where new neural pathways form and strengthen. This entire shift is clearly explained in Abdaal's core mantra about memory. Memorization comes from repeated recall, not repeated exposure. Now read that again. Repeated recall, not repeated exposure. That single sentence rejects every passive study technique that feels productive but isn't. Yes, I'm talking about rereading, highlighting, summarizing with the book open. Students gravitate toward these because they offer immediate gratification and reinforce that dangerous fluency illusion. But what they don't do is build lasting memory. Abdaal's system fundamentally replaces these low-utility passive methods with high-utility active ones, with retrieval at its core. And they feel frustrating in the moment because they're harder, but the long-term retention gains are massive. One more piece before we touch subject matter, meta-learning. And you need to understand the importance of this. This refers to the preparation, the groundwork before diving into content that can dramatically accelerate everything that follows. You know that old saying, if you need 6 hours to chop a tree, spend the first 4 sharpening the axe. Well, in learning terms this means, before jumping into Python, Spanish or piano, spend time learning how people best learn that specific thing. Take the time to understand what are the common pitfalls, what are the most effective methods for that skill. You need to learn how to learn the subject first. You may ask, but what practical difference does this make? Well, it prevents you from blindly using generic methods that might be suboptimal. Watch this. When Abdaal decided to learn piano, he didn't just grab a beginner's book. He spent time in music theory subreddits, blogs about learning piano by ear versus sight reading, watching videos analyzing common mistakes beginners make. That preparation gave him a superior strategy, the meta-learning for piano, and significantly cut the total time to competence. He invested effort upfront to optimize the entire path. Now we get to the critical implementation phase. Active recall, spacing, and interleaving are the 3 evidence-based pillars forming the foundation. Let's start with pillar 1, active recall. If you take away one technique from this entire deep dive, make it this one. Active recall consistently shows it is the single most effective method for transferring information into long-term memory. In order to understand it, you need to understand this question first. Why is testing yourself once superior to reading the same page 4 times? Well, it comes down to what the brain actually needs for successful encoding. To lock something into long-term memory, your brain must actively retrieve it. Recognition alone isn't enough. The act of retrieving is critical. When you successfully recall a fact or concept, you're igniting the entire neural pathway associated with that memory. That effortful retrieval physically strengthens the connection between neurons, like exercising a muscle. There's also the encoding specificity principle. The way you retrieve information during practice should ideally match how you will need to retrieve it later, in an exam for instance. Forced retrieval practice builds that strong, accessible pathway. Abdaal's recommendation for daily implementation is this: convert lecture notes into questions immediately after class. But here's the crucial twist. Treat testing not just as an assessment of what you have learned, but as part of the initial learning process itself. The idea is to start testing yourself on the material before you feel ready. This is something called pre-testing. Why, you may ask? Well, because it primes your brain. It exposes gaps in your knowledge up front. Then, when you study the material, your brain pays far more attention to filling those specific gaps. The learning becomes targeted and effective. Here is how to take this to the next level. Esight's method, named after Abdaal's friend who ranked first in his year at Cambridge Medical School. Esight took the concept of desirable difficulty and pushed it to its maximum potential. He converted all his learning materials, every lecture slide, every textbook chapter, into massive question lists. 216 distinct questions just for the one challenging module. But here's what made it brutal. He didn't write the answers anywhere near the questions. Not on the same page, not on the back of a card, nothing. 216 questions with no readily available answers. This is intentionally high friction. So how did he revise it then? It turns out the revision was the process of answering. He'd encounter a question and attempt to answer completely from memory by writing it out or speaking aloud. Unlike the standard approach, if he drew a blank, he couldn't simply flip the card over. Instead, he forced himself to return to the original source material, the textbook chapter or the lecture notes, and hunt down the answer and its surrounding context. The effort of searching became the learning mechanism. That struggle, that forced engagement, having to reread context to find the specific information, it makes learning stick exponentially better. Your brain assigns higher value to information it had to work hard to retrieve versus something passively glimpsed on a flashcard back. This is maximizing the pain of not knowing. Active recall supercharged with desirable difficulty. Pillar 2. Spaced repetition. Active recall is the how. The next question is when to do it. That brings us to spacing, the direct method against the forgetting curve. Ebbinghaus discovered this in the 1800s. If we don't review information, we forget it exponentially. You can lose half of what you learned within hours or days. It's harsh. Spaced repetition fights that curve with timing. Instead of cramming everything once, which is stressful and ineffective for long-term memory, you review topics at specifically timed increases increasing intervals. Learn something today, review it tomorrow, then again in 3 days, then a week, then a month. Escalating. Why do increasing intervals matter? Well, because each time you've allowed yourself to forget a little. Your brain must work harder to retrieve that information compared to recalling something you saw 5 minutes ago. That extra retrieval effort strengthens the memory trace far more effectively. Desirable difficulty through timing. You are leveraging the forgetting curve to enhance learning. The mindset shift here matters. It's consistency over intensity. A little consistent effort each day far outperforms those nightmare marathon cramming sessions before exams and causes less stress. Plus, it's efficient. You are only reviewing when you actually need it. When it's getting weak, you are not wasting time on material you already know well. Pillar 3. Interleaving. Mixing things up to keep the brain engaged. This is strategically switching between different topics or problem types within a single study session. Instead of dedicating 3 solid hours to calculus derivatives, which feels focused, you might do an hour of derivatives, deliberately switch to integration problems, perhaps some differential equations, then circle back to derivatives later. Why would constantly shifting gears benefit learning? Doesn't it break concentration? It seems like it might, but there's a powerful cognitive benefit. Block practice. Studying one topic extensively lets your brain settle into a groove. It uses the same rules, the same cognitive processes repeatedly. It becomes easier. The fluency illusion creeps back in. Interleaving prevents that. By constantly switching between derivative problems and integration problems, you force your brain to continually retrieve and apply different rule sets, different solution strategies, different mathematical approaches. It must work harder to figure out which approach suits this specific problem. That struggle actually strengthens learning for each individual subject more effectively than isolated study. Your understanding becomes more flexible. You see distinctions and connections between topics better. Abdaal uses this deliberately with something called the switch test. If he starts feeling comfortable with a topic, this is flowing nicely, I'm quite enjoying this, that comfortable, satisfying feeling becomes his signal. He immediately switches tasks, because comfort is the enemy of learning in this model. The switch test ensures he is always operating near the edge of his cognitive comfort zone, maximizing effort, therefore maximizing learning. But I need to clarify, he wouldn't do this for brand new, intensely difficult material. The difficulty already exists there. Interleaving works best for subjects where you're gaining familiarity, where that dangerous fluency might creep in. Section 3. The Strategic Toolkit. Understanding principles is half the battle. You need concrete systems to implement them consistently, day after day. We are going to start with the Retrospective Revision Timetable, also called RRTT. This tackles planning. It's designed as a direct fix for traditional study plan failures. We've all made those beautiful color-coded prospective timetables. Tuesday, 3 p.m. Chapter 4 notes. Wednesday, 10 a.m. practice questions. They look fantastic and they almost always collapse. Life happens, topics take longer than estimated, you fail behind, feel guilty, maybe abandon the plan entirely. The RRTT flips the script. It's reactive, not predictive. Usually, it's a live document. In Google Sheets, Notion, you name it. Tracking just 3 simple things for every topic you need to learn. What topic did you study? When did you last study it? How well do you know it? That third element is where the magic happens. Start with dynamic color coding, red, yellow, green. Red means I'm struggling, this feels weak, urgent review needed. Yellow is for I sort of know it, but it's shaky, needs more work, not critical right now. Green, I know this well, feeling confident, ready for a much longer spacing interval before the next review. This fights our tendency to review easy material because it feels good. Instead, the RRTT forces confrontation with weaknesses daily. The guiding question isn't what's on my schedule. It is, if the exam were tomorrow, what single topic would I be least happy about seeing? The RRTT points you straight to it. You look for the topic marked red that you haven't reviewed in the longest time. If no reds exist, the oldest yellow. It automatically implements spaced repetition based on your actual confidence level, not a predefined schedule. You are always working on your weakest link. Maximum return on your study time. No more polishing concepts you already know. Ruthless focus where it's needed most. Practically, it gives you an overview. It forces you to define the subject scope upfront by listing every topic. As exams approach, one glance at the sheet shows visual progress. How many reds and yellow remain? Much more manageable, and less anxiety-inducing than facing vague overwhelm. It eliminates the procrastination of constantly making and remaking plans. The plan is always alive, adapting to your reality. Now, let's continue with tool number 2, Anki. Anki is a digital spaced repetition flashcard software. What makes it powerful? Fundamentally, it automates the scheduling complexity of spaced repetition. You don't manually track when to review which flashcard. The algorithm handles it based on how easily you recall answers. It directly facilitates active recall. Question on one side, answer on the other. Plus, it's free on Windows desktop and Android. On iOS, costs money, but there are other free options. What you need to know is that Anki isn't just simple Q&A cards. Its power comes from different card types for different information. Type 1. Basic reverse cards. Good for simple facts, definitions, vocabulary. Question on one side, answer on the other. Or vice versa. Standard flashcard territory. Type 2. Closed deletions. Incredibly useful. Imagine filling the blank for sentences or key facts. Anki prompts you to recall the missing word. You recall the information in context, which works better for certain material than standalone questions. Type 3. Image occlusion. Game changer for visual subjects like architecture blueprints, circuit diagrams, historical maps, musical notation, design compositions. You take an image like a labeled architecture floor plan or a circuit schematic with component labels and draw boxes over labels, blanking them out. Then Anki shows you the image with blanks, so you must actively recall what label belongs in each hidden box. You can set it to test each label individually. Forces retrieval practice directly onto visual and spatial memory. Very powerful. Quick capture, the friction solution. The major sticking point is that creating cards takes time and feels like a chore. Abdaal solution? Quick capture. Instead of thinking, I need to turn this entire textbook chapter into Anki cards, which is daunting and time consuming, integrate card creation into practice. Primarily through online question banks, practice tests, and end of chapter questions. When you inevitably get a question wrong, which you will if you're using desirable difficulty, immediately copy and paste the question, correct answer, and explanation straight into an Anki card. In this way, you are capturing the knowledge gap precisely when it's revealed. It minimizes the friction of thinking up cards later. Also, ensures cards you create are hyper-relevant to your specific weaknesses. Building your deck based on your errors. Far more efficient workflow. The critical Anki pitfall. Here's the critical point. Anki is phenomenal for details, but has a big picture problem. It excels at drilling individual facts, definitions, and process steps. But if you only use studying with Anki, you can end up knowing hundreds, maybe thousands of isolated facts about the subject, let's say European history, but have absolutely no idea how they fit together. You may know all the treaty names and dates, but can't explain how diplomatic relationships actually shifted across the continent and why conflicts emerged. Essentially, you lose the forest for the trees. You lack context and structure. The solution is mind maps. Anki must be combined with methods focusing on structure, primarily mind maps or spider diagrams. Pen and paper or digital, the tool matters less than the process. The purpose is to visualize connections, hierarchy, how big concepts break down into smaller ones and how they relate to each other. And you use active recall with mind maps too. You don't just look at your beautiful mind map, you try to redraw it from memory. This is active recall applied to knowledge structure, not just individual facts. Anki handles fine-grained details. Mind maps handle overall architecture. This is probably the biggest mistake beginners make with Anki. Using default settings. The defaults are frankly not optimized for robust long-term learning. They are designed to move new cards into the graduated state, where Anki considers them learned and shows them at very long intervals far too quickly. Often after seeing the card correctly just twice, within minutes of first learning it. You see it, get it right 10 minutes later, and Anki thinks you've mastered it. But that's almost certainly just short-term memory working. You haven't actually consolidated properly. You're tricking the algorithm and yourself into false confidence. What needs changing? Adjust the steps for new cards and the graduating interval. Steps define the initial intervals Anki uses when you're first learning a card. The default might be 1 minute, then 10 minutes. Get it right at both points. It graduates. It's way too fast. You need more steps with increased time. Abdaal and many Anki experts recommend setting forcing you to recall the card successfully multiple times over increasing spans before graduation. For example, 1 minute, 10 minutes, 1 day, 3 days. Only after successfully recalling after a 3-day gap would it hit the graduation interval. The graduating interval itself should be longer too. Instead of graduating to maybe a 1-day interval initially, set it to 7 days or even 15 days. Exact numbers can be tweaked, but the principle is crucial. Force multiple successful retrievals over several days before the card enters long-term review schedule. You are deliberately building in time for forgetting even in early stages, manufacturing desirable difficulty within the Anki algorithm itself, ensuring the card has made it into slightly more durable storage before you let intervals get really long. There are other settings like the ease factor, controlling how much the interval increases or decreases based on your answers. Many suggest tweaking that too, so that getting a card wrong once doesn't completely reset its progress. Taking time to understand and customize these Anki settings transforms it from a fancy flashcard app into a genuinely powerful personalized learning tool. Skipping customization is probably the single biggest reason people try Anki and feel it doesn't work for them long term. You have to tune the engine. Section 4. Sustaining the system. The best system in the world is useless if you don't actually use it consistently. The best blueprint doesn't build the house by itself. Friction and focus. So you need to find a way to manage friction and focus. You want to make it as easy as possible. Reduce friction for things you want to do, focus, study. Simultaneously make it harder, increase friction for things you don't want to do, like getting distracted. How can you reduce friction for focus? Crutch 1. Instrumental music only. Use instrumental music, not music with lyrics. Why so specific? Well, it comes down to how working memory functions. Specifically, the phonological loop, the part of short-term working memory handling sounds, especially language-based sounds, your inner ear and inner voice. When you're reading complex text or rehearsing facts mentally, you're actively using that loop, that internal monologue. If you're listening to music with lyrics, those words, even if you're not consciously paying attention, compete for resources in the same limited phonological loop. It creates interference and clogs the system. It demands cognitive resources you need for your primary learning task. Instrumental music tends to be processed differently. It engages other auditory centers and generally doesn't interfere with verbal processing needed for studying. Instrumental soundtracks, classical music, lofi beats, these are all acceptable. Podcasts or lyrical pop, keep them out during deep work. Reducing that auditory friction can make a surprising difference. Crutch 2. The 5-minute rule. For overcoming the psychological friction. The classic procrastination hurdle of simply getting started when motivation is low, you need the 5-minute rule. Commit to just 5 minutes. Tell yourself, I'm just going to sit down and work on this seemingly daunting task for only 5 minutes. Abdaal notes, and many agree, that very often getting over that initial hump of starting is the hardest part. Once you're 5 minutes in, inertia is broken, you've generated momentum, and you'll likely keep going much longer. Bypasses the brain's initial resistance and lowers the activation energy required to begin. Increasing friction for distraction. The single most effective thing, physical distance. Put your phone across the room or in another room while studying. Out of sight, out of mind, or at least out of easy reach. If that's insufficient, actively increase the friction needed to access distracting apps or websites. Uninstall social media apps from your phone. Force yourself to log in through a web browser each time you want to check them. That extra couple of steps, that added hassle, that friction, is often enough for your prefrontal cortex to kick in and ask, wait, do I really need to check Instagram right now? Is it worth breaking my steady state for this? Often, the answer is no. So the friction wins, making desired behavior like focus easier and undesired behavior like distraction harder. Learning in community. Humans are social creatures. Leveraging that can boost productivity and well-being. Studying doesn't have to be solitary grind. Study groups or even just studying alongside friends can be powerful. You can use the Pomodoro technique in group settings. Pomodoro typically consists of 25 minutes focused work, then a 5-minute break. Now, imagine doing those focused 25-minute sprints in the library or on a video call with friends, even if you're all working on different subjects. Then, you all take the 5-minute break together. Chat, grab coffee, whatever. Creates shared rhythm. Abdaal calls this a Pomodoro society. Turn studying from potentially lonely chore into more shared positive experience, boosts motivation, and provides accountability. You see friends working, so you work. Makes intense study periods less isolating and more sustainable. Within group settings, leverage collaborative active recall. Friends quiz each other. Testing someone else forces you to retrieve information to formulate the question. Being tested, on the other hand, forces retrieval on their end. Saying answers aloud adds another encoding layer versus just thinking about them. Sharing work, notes, essay plans can be efficient too. If you have a huge list of potential essay topics for an exam, split them up. You and 2 friends each deeply plan out 10 different essays. Then share your plans. You instantly get access to structure and key points for 30 essays instead of just 10. Economy of scale. I need to give you a critical warning here. If you use someone else's notes or essay plan, Abdaal strongly cautions you must process it yourself. Add your own interpretation, your own analysis. Rewrite it in your own words. Reorganize the structure to match your thinking. Add your own examples, counter-arguments, or insights. If you simply memorize and repeat someone else's plan word for word, evaluators will often notice. More importantly, you haven't truly internalized the material yourself. You're borrowing understanding, not building it. Collaborate, yes, but always synthesize and make it your own. Holistic health, sleep, and exercise. Beyond the desk and study group, the system emphasizes broader context. You can have the perfect study system, but if your body and mind aren't functioning well, your cognitive engine simply won't perform optimally. 2 absolute pillars: sleep and exercise. Non-negotiable. Sleep's role: memory consolidation. During certain sleep phases, your brain takes memories formed during the day, processes them, strengthens the important ones, and transfers them from fragile short-term stores like the hippocampus to more durable long-term storage in the cortex. Pulling an all-nighter before an exam literally sabotages all the learning you did the day before. You are preventing the consolidation process. Consistent sufficient sleep is paramount for making knowledge stick. Exercise beyond stress relief. Exercise has been shown to induce profound structural brain plasticity. What does that mean? Exercise can actually change the physical structure and function of your brain in ways that support learning. We're talking about neurogenesis, actual growth of new neurons, especially in the hippocampus, improved blood flow to the brain, enhanced executive functions like focus, planning, and working memory. Exercise isn't just good for your body, it's literally upgrading your brain's hardware for learning. Making regular exercise part of your routine is a direct investment in your capacity to learn effectively. Enjoying the journey. Tied into this balance is the overall ethos. The whole point of creating such an efficient learning system isn't just to get good grades. It's to do so without sacrificing your entire life and well-being. Avoid the trap of deferred happiness. I'll be happy when the exams are over. The system should create space for life during the process. It aims to maximize efficiency so you don't have to study 12 hours daily. You can learn effectively, get good results, and still have time for friends, hobbies, exercise, sleep. Enjoying each day for its own sake, not just enduring it until you reach the destination. This is a much healthier perspective. Overlearning and feedback. For sustaining things long term, especially when you start getting good at something, you need overlearning and feedback. Once you move beyond beginner stages and become reasonably proficient, the path to true mastery involves 2 things. First, actively seeking out critical and constructive feedback, not just praise. Praise feels good, but critique helps you improve. Praise confirms what you did well. Critique highlights where you can get better. Second, overlearning. This isn't just about practicing more, it's about digging deeper. Continuously asking why. Don't just memorize the rule, the formula, the historical pattern. Understand the rationale behind it. What are the underlying principles? Why does this pattern exist? What's the evidence? What are the exceptions? You need to move beyond memorization to true comprehension and application. That deeper understanding of the why allows you to apply knowledge flexibly in new situations, whether debugging code in unfamiliar languages, analyzing historical events you've never studied, or adapting business strategies to novel markets, rather than just repeating facts. Ali Abdaal's system represents a fundamental shift. Moving away entirely from the brute force, work harder, more hours mindset towards strategically working smarter by relentlessly focusing on active retrieval, leveraging spacing and interleaving, using tools like RRTT and Anki intelligently, making knowledge stick efficiently. hopefully with less stress. You now have the blueprints, the schematic for a system grounded not just in one person's anecdote, but in cognitive science and used by proven top performers. The power of the methods themselves isn't in doubt. They are scientifically validated. The real challenge, as always, implementation, consistency, the discipline to actually do it day after day, especially when it feels hard, which, as we established, it often should. Speaking of that challenge, there is a provocative idea about motivation, an infantile fantasy that should be replaced by discipline. Harsh, but it cuts to the core of the consistency problem. We can't always rely on feeling motivated. Motivation ebbs and flows. It's unreliable. If you base study habits on waiting to feel motivated, you'll be inconsistent. Discipline. Building a reliable system and habits. That's what carries you through when motivation inevitably dips. So how do you deal with resistance, especially on day one when maybe the system feels new and the friction is high? Here's my final provocative thought for you. What if the single most productive thing you could do starting today to build and sustain your own effective learning system isn't about trying to somehow find more motivation each morning? What if it's simpler? What if it's about identifying and removing one single piece of friction from your processes every single day? Whether that's a technical friction, like finally customizing those Anki settings, or a psychological one, setting out your study materials the night before. Focus on tuning the machine, the system, rather than wrestling with your feelings about using it. Make the system itself smoother, easier to engage with, incrementally, day by day. Because maybe the relentless focus on refining the system, removing those tiny barriers, maybe that is the key to building the discipline and consistency where true low-stress mastery actually begins. Focus on the system, remove the friction. Thank you for joining me at the Meta Learner. I'll see you next time.